Welcome back to another tutorial in this series, Algorithmic Trading and Investing with the DARWIN API. And so far, if you followed along, we've covered practically everything in terms of implementation of endpoints in the DARWIN Info API. So today, we're going to dedicate this tutorial to putting everything together, or at least most of everything together that we've done so far with the DARWIN Info API into an implementation that for this tutorial will focus on visualizing Darwin filters. Now, if you've used the Darwinex platform, you know you can set up filters per the different criteria as we discussed last time. You can also achieve the same via the DARWIN Info API as we covered in a previous tutorial, where we constructed this function called getFilteredDarwins that essentially accesses the /products post endpoint, supplies filters, order criteria, and downloads a list of Darwins that satisfy that criteria at the point in time at which the query is executed. What we'll cover today is how to visualize these filters on a price chart to make them look like this. So by default, this chart you see right now is showing you all Darwins that fit one or more filters that we're going to define in today's implementation. And then we'll cycle through all the filters we've defined and see how they visualize on this chart. You'll also be provided with the logic on how to construct this, as well as the implementation in terms of visualizing these on a Plotly chart, all the different components that are required in order for you to do that, and of course the source code of the completed solution that led to this chart. Now, in previous tutorials, we've covered getting quotes, constructing filters, getting scores, downloading Darwin universes, etc. So there's a lot that we've covered. We're going to use some of that for implementing a visualizer for filters, and that will entail downloading quotes for our universe of Darwins that satisfies the filter. Filtered Darwins to begin with. So we're going to access the API and download a list of Darwins that at this point in time satisfy a list of filters that we're going to supply to the endpoint. Over here, for example, in our default implementation that we did in the previous tutorial, we specified a very basic drawdown and return filter. We're going to do that again in a new implementation today in test filter visualizations, which is an implementation that encompasses downloading a filter of Darwins, downloading quotes for those Darwins, and constructing a graphics Plotly object to render all of that information on a Plotly chart like this. All source code will be provided to you at the end of this tutorial. Also, the Plotly chart implementation relies on DWX graphics helpers, which is something that you've been provided previous tutorials in a more minimalistic form. For today's implementation, we've added some code to it in order to engineer, of course, the chart that you see here, dropdowns, different datasets being triggered by clicking different points in the dropdown, etc. But also, more importantly, for generating the data that is consumable by Plotly, we've added a little function that allows us to create a list of scatter objects for each filter that we're going to supply to the implementation. So let's start from the very top, going through a very quick recap of what we did last time that we will use today. So primarily that will be getFilteredDarwins. Now, in the getFilteredDarwins function, you remember that we had filters supplied and order supplied. The filters are the criteria and the minimum and maximum values over the period that we're interested in. And the order is the ranking order that we'd like to receive the output in. So in our case, in the default getFilteredDarwins implementation we did in a previous tutorial, we used return over the last 12 months in descending order as the ranking criteria for the output that we'd like to receive in the form of Darwins. We implemented the code for this function, as you saw in that tutorial. What we're going to do today, in addition to using getFilteredDarwins, is get historical quotes again. We've done a couple of examples over previous tutorials with this. Today, in particular, we're going to firstly execute some filters, call the API with those filters, download a list of Darwins for each of those filters, aggregate that into one list of unique Darwins, and access the DWX historical quotes, getHistoricalQuotes function, supplying the tickers of those Darwins as symbols to this function, downloading all the quotes data, constructing one mega data frame, and then doing things with it. For this to happen, we've written a separate class here called testFilterVisualizations that iterates through this process that I just talked about. In this class, we're basically going to do what we've done before in previous implementations. We'll create an instance of the Darwinex Info API. here's a variable called underscore dataset that we've declared here to store temporarily any output we get from the API in memory. So we don't have to constantly call the API again for the same information that we already had or had received before and could have just saved. We're also going to create an instance of our graphics object, which is DWX graphics helpers. And this has been modified to essentially create another type of chart in addition to the previous chart that we had, plotly data frame scatter. And this chart is essentially going to add some layout components that allow us to create dropdowns, interchange between datasets, one dataset belonging to a particular filter of Darwins, so on and so forth. So this code has been updated for you. We won't delve too much into the detail of the graphics implementation. You can read through the graphics code as well as consult Plotly documentation for that. The important thing here is to go through the visualization aspect of filters and of course how to generate those filters in the first place. So there are a few ways to go about creating filters. Your own experience, intuition, ideas you may have seen on the platform, and generally from having studied the investment attributes of Darwin's in particular, your thoughts on what combination of attributes would serve your purposes well to create a filter for come into play. Of course, backtesting through some exercise whereby you're feeding all Darwin investment attributes as features into an algorithm that is able to then give you some sort of estimate of the variance in the backtest being supported primarily by a few attributes, or the unexplained alpha in a particular backtest you've done being attributed to certain attributes. All those factors can come into play in engineering a filter. This tutorial is more about deploying those filters live on a chart. And for that, we've gone ahead and first added our default filter that we used in our get filtered Darwin's implementation in a previous video. And we've added 6 additional filters. Now, as we described in the previous tutorial, we have the ability to call the API with filters created using investment attributes as well as underlying attributes such as drawdown and return. For this implementation, we've constructed a D-score greater than 75, performance greater than 9.5, same for positive risk consistency and open strategy. Now, the 9.5 value is very restrictive, as you probably gathered. It will essentially eliminate a lot of the Darwins from being received into the filter. And this hasn't been done because 9.5 is some magical value for getting a good Darwin. It's so that the number of Darwins on our chart here are a manageable amount and don't clutter the chart or don't consume too much memory, so that the chart itself, the experience of visualizing these filters on the chart is compromised. Hence the use of 9.5 and 75 and those sorts of very restrictive figures on these investment attributes as well as underlying attributes are done deliberately to achieve this effect of having a chart that is viewable just enough so that it doesn't compromise performance in terms of our viewership of it. These two filters in particular are something that we talked about in a blog post in 2017 titled How to Identify Overfit Trading Strategies. And if you haven't seen it, then let's quickly go over to it to delve into the thought process behind these filters that we just created here. In this blog post, we discussed typically 3 combinations of scores using all the attributes available that demonstrate consistent performance between backtesting and live trading environments, when accompanied by high experience, high market correlation, and high risk stability scores. And we outlined 3 generalized combinations that could achieve this effect. And these included the first one being low capacity, high open strategy, close strategy, high performance, and high negative risk consistency. Then the second one was moderate capacity, high loss aversion, and high performance scores. And the third one was high performance, very high positive and negative risk consistency or duration consistency, coupled with moderate levels of loss aversion, moderate scores for loss aversion. For this implementation, we're going to focus on the first 2. The third one is quite idealistic and very, very conservative. So while it may well lead to Darwin's being part of the filter, we're going to focus on the first 2 that will give us at least a few to visualize on a chart and not have an empty chart to look at. In terms of interpretation of low, high, moderate, these terms, we've taken some approximations, and in our code, with low, high, and moderate, we've defined some ranges of numbers. These are not fixed or set in stone. You can completely change your interpretation of high, low, or moderate. But in this particular case, we've interpreted high, low, and moderate as anything above 9 being very high, anything moderate being 4 to 6, and high generally being 7 and above, low being less than 4. So these interpretations have led us to engineer these 2 additional filters where we've set capacity to less than 3, open strategy greater than 7, closed strategy also greater than 7, performance also greater than 7, including negative risk consistency as well being greater than 7. And the article also mentioned that all of these need to be accompanied by high scores in experience, market correlation, and risk stability. So we've implemented that by specifying a lower limit of 9 for those 3 scores and constructed this filter as we showed you in the previous tutorial. Same for the second filter, where we've set capacity to between 4 and 6, loss aversion greater than 9, very restrictive, performance also greater than 9, and EX, MC, and RS also greater than 9. So a very restrictive filter here compared to the previous one, and that one being a lot more restrictive than previous ones, and so on and so forth. So this gives us a good mix of filters to work with for this implementation. As you can see on the right-hand side, the number of Darwins in them are a manageable number of Darwins to visualize on a chart, and each of them give us at least some Darwins to look at, thereby allowing us to demonstrate that you can execute simple filters, and you can also execute very complex filters via the API, all through your programming language of choice, in this case Python, and basically get outputs that you can do things with and conduct research on. So that covers how we went about getting the filters together. And now let's describe how we wrote the code, how we structured the code. Of course, as mentioned in previous tutorials, this isn't set in stone. This code is written in a manner that enables education. So it's deliberately long-winded and heavily commented and things like that. We have made use of some efficiencies, such as list and dictionary comprehensions in places, but where we feel that there's no need to vectorize a solution that is better explained by implementing slightly longer code, we've done that too. That doesn't mean that that's the only way to do it, and you are absolutely free to download this code and change it to your particular preferences. Now, in terms of taking each filter specified in our class, let's just quickly go through the structure of the class again. So I set up our info API object and our graphics object. We specify a little temporary class variable called dataset, in which we'll store our outputs retrieved for quotes and filters. Then inside the class, we have another function called run, and this run function essentially encapsulates all the logic and the functionality we'd like to use in order to engineer this chart. So what happens inside this function? Firstly, we take a look at the filters, and for each filter in the provided list, we download the Darwins corresponding to that filter. Now, once you've downloaded all the Darwins for each of your filters, it's likely that Darwins that are part of one filter may also be part of other filters. So it makes little sense to execute queries to the API for the same list of Darwins over and over again. Instead, if we can just download all Darwins that are in this universe of filters, then we can cycle through them and capture only the data for the Darwins that fit our particular filter, the one we're visualizing on the chart. To achieve this, we go ahead and execute a call to get historical quotes for the set of Darwins that have been returned to us in each of the filters. And set by default will give us unique values. This will limit the number of queries we make to the DARWIN Info API and allow us to still download the data for all the Darwins that are in this universe of filters. Once we've done that, we go ahead and start creating our graphics objects and all the components we need for those graphics objects. And these include creating scatter charts, creating a list of Plotly scatter objects, which we then need to align and create corresponding menu items for, so that when we load this chart, we can cycle through our filters one by one through the use of a dropdown. And finally, once we have all our data prepared, we store it temporarily in our dataset variable as a class variable, so that if we need to plot it again, we don't have to make all these calls to the API over and over again. There is logic in particular over here to do with constructing the array of data for Plotly in order for us to cycle through different data sets in Plotly. So to make sense of this, take a look at this chart again before we hit the run button and engineer the chart again. Each of these drop-down items triggers an array of Boolean values, true and false. So what we've had to do is, from the Plotly documentation, we've engineered one massive array of scatters. And each of those scatters will have a Boolean response variable that will be accessed by the drop-down menu over here. Each drop-down is going to trigger the dataset that it corresponds to in our massive Plotly array. So to do that, we've constructed the Plotly array over here. And each time we want to load a particular filter, then the name of that filter along with the total stack length is specified. And this function essentially goes ahead and sets everything except that filter's locations in our massive graphics array to false, thereby making only that filter visible to us. So that functionality presents itself in this manner. So right now, if we were to simply load the chart as is, we would see all Darwins that are in our filter universe as we've downloaded via the /products post endpoint, these being over here. Once we've loaded the chart, we execute each function via the drop-down menu. Each filter then gets executed accordingly. And once we click on a particular item, then that particular item's corresponding filter is loaded on the chart, and every other time series that was in our universe gets set to false, essentially gets disabled. That's the logic of the Plotly chart generation, where you have more than one data set that you'd like to show on your chart. And that's it. The code for this has been written here, and the implementation for getting the chart up and running has been added to DWX graphics helpers for your convenience. And that's essentially it. So the structure is very simple. The class takes a list of filters. It goes ahead and downloads Darwins that correspond to those filters at this point in time. It then gets quotes for all those Darwins. It doesn't call the API over and over again for the same Darwin. Instead, it accesses data in a set of unique Darwins and then cycles through them accordingly using the filter values. Once we've done that, we construct a scatter stack, which is a scatter plot stack, and we send it off to Plotly for rendering on the chart. And that's all there is to it. This will allow us to take a filter of Darwins and visualize them on a chart. So this is the output that you receive. So while we're examining this chart again, I'm going to go ahead and execute the run function so that in the background, it starts getting all the filters together, downloading all the data for those filters, and starts to prepare the scatter stack for us to render on our Plotly chart. And now, while those Darwins are getting downloaded, as you can see, the entire universe of filters encapsulates 243 Darwins. So that is a lot of Darwins to download and render on the chart at the same time. Hence the use of filters and a dropdown to segregate this information by filter. And the end product will be this. So the very first return drawdown default filter is the one we used in our tutorial video where we showed you how to create the get filtered Darwins function to begin with, accessing the /products post endpoint. And here the universe, as you can see, is quite diverse. You have very good Darwins, you have very bad Darwins, and you have mediocre Darwins. The point is that they're all visualized here for you to see their evolution over time. You don't have to just have one view here where you have all the Darwins visualized here together. You can, if you spot a Darwin in this very large universe that you feel is worth your attention, then you can go ahead and double click its corresponding legend item in the right hand section of your chart and visualize it independently as well. That's the benefit of using Plotly. Plotly has some very neat features such as this, whereby you can take very large data sets and isolate time series of interest as well. Then the second filter that we had was D-score greater than 75. By clicking that filter item on the dropdown, we get its corresponding Darwins over here. As you can see, being a restrictive filter at 75 and above, the number of Darwins is drastically reduced compared to the previous no filter applied visual we had. The next one being performance greater than 9.5. And again, please bear in mind that when you execute a query to the /products endpoint via get filtered Darwins, you are getting Darwins that have these filter values at this point in time. This is not something you would use for backtesting. However, once you do create these filters and render them on a chart like this, it's always an interesting exercise to go back in time and see how they evolved over time. There will be points in their evolution where they did not have the filter score that they have today, but it's still a good exercise to sort of develop some intuition about a particular filter before you consider including it in your backtest or doing some more formal backtesting with it, as we'll cover in future tutorials. Then you have positive risk consistency, again a restrictive filter at 9.5, still returned to us quite a few Darwins. And then we have open strategy greater than 9.5. What's interesting about visualizing data this way is that you can take a look at values that on the surface, open strategy being greater than 9.5 will lead you to conclude that the Darwin is very good at opening trades. But that does not necessarily translate into consistent performance or profitability over time, as you can see from a lot of the Darwins that, despite having a very high score for open strategy at this point in time, historically have not been at those levels or have not performed well. So this is a good way to confirm that when you execute a filter, that filter tells you the picture for this point in time. And historically, the same filter does not apply. You would have to conduct a backtest where you would have to check this information at each time point in your backtest and then conduct your backtest accordingly. Finally, we have the two filters that we talked about, having taken them through our How to Identify Overfit Trading Strategies article. And the first one being CP less than 3, OS greater than 7, all the way through to RS greater than 9. As you can see, these are very restrictive filters. And in the article, this is what we covered, that there are very few Darwins who will meet these criteria. And that is apparent here because the number of Darwins that satisfy this criteria right now at this point in time are fairly few. It's about 6 in total over here. What's interesting to note is that despite the query being for scores achieved at this point in time, or scores prevalent at this point in time, historically, such Darwins have performed fairly consistently, despite those scores only being valid at this point in time. So that's an interesting observation when you take a look at this particular filter, this restrictive filter. The second one being capacity being between 4 and 6, loss aversion being greater than 9, everything else being greater than 9 as well, is a super restrictive filter, and that has been able to isolate only 2 Darwins, which is statistically insignificant a sample for us to conclude in terms of wanting to conduct backtests on or analyzing further for alpha. However, it's still a filter that has rendered Darwins, and it's still interesting to look at. So at the end of the day, what we've achieved is the ability to take our universe of filters, download all Darwins that fall into those filters, and visualize all of their data via the quotes functionality that we have put together in previous videos. We've then added code for creating a Plotly object, a chart that allows us to segregate this information by filter. And we've created corresponding menus and corresponding scatter stacks to achieve that. We've then rendered all of this information on a Plotly chart and given ourselves a convenient dropdown for us to take a look at each filter in isolation. This is one of the major benefits of using the Darwin API, in that you can take use cases that you're already used to since you've been using the Darwinex platform and add layers of analysis on top. In this case, what we've managed to achieve is take a raw filter that we've downloaded in terms of just the number of symbols. This is something that we would have seen on the platform, is the list of symbols accompanied by clickable links to each of their Darwins. What we can achieve via the API is a lot more than that, in that we can download all the histories for the Darwins that fall into our filter and visualize them as portfolios of Darwins in that filter. In future tutorials, we'll also be covering how to visualize your existing portfolio of Darwins, be that live or demo, in this way. And we'll also cover how to achieve that effect in real time using the Quotes API and the WebSocket API. So hopefully you've enjoyed this tutorial. The tutorial was heavy on graphics implementation, but also very heavy on conducting alpha research via Darwin filters. So if you've enjoyed it, there will be a lot more to come in future as we're covering backtesting going forward. And in backtesting, there are several use cases for filters, of course, but more importantly, there is additional logic to be considered in how you go about constructing your backtest with assets such as Darwin's or any other asset in your portfolio. Thank you. As always, if you enjoyed this presentation, please do consider sharing it with your social networks, colleagues, co-workers, and friends. And do subscribe to the Darwinex YouTube channel so you remain up to date with all future videos that will be released in this series and other topics discussed on Darwinex. Thank you very much for your attention. See you next time.